In this video, we're going to investigate something called the factorial. In mathematics, factorial, like 6 factorial, is defined to be the product of all the numbers, integer numbers, from 6 all the way down to 1. Don't be confused with how we've been using the exclamation mark symbol with Boolean logic and with conditionals where it means not. In mathematics, the exclamation mark has the meaning of factorial, or multiply a whole bunch of numbers together. Now, what we'd like to do is write code that will calculate this, and it looks like a pretty good situation to use a loop. To get this to work in this situation, I'm going to actually write another method to show you how we can use methods and loops together. So what I'd like to be able to do is say I have a variable that's going to hold the answer, and that answer is going to come from a function which will take an input, and then I can print out the value that is returned from that function. Now, of course, for this to work, I need a separate method down here. So it's going to be public static. Because the value returned from the method is an integer, I will write int here. Because the name of the function is factorial, I'll write factorial. And it has an input, which is an integer. So I'll have an integer input. And then you'll notice I get an error here, which means that Java expects me to return a value. So to make it happy, I'll make it return 1. So to demonstrate this running, if I run it, it says the answer is 1 because when 6 goes in here, the program says, I don't care, I'm going to return 1 anyway. That'll go into the answer variable and it prints that out. So now we need to go through and actually implement the factorial function. So we're going to have to multiply a bunch of numbers together. And we've already learned how to add a bunch of numbers together. We need an accumulator. But this time, because we're multiplying numbers together, we need a different initial value. If we made this 0, then multiplying this by numbers would not change it, because 0 times anything is still 0. So our accumulator actually needs to start at 1, and then we need a loop, which will go over all the numbers from 1 up to n, and each of those numbers need to be multiplied into the product. At the very end, if I return the accumulated value, we should be done. If I run it, it says 720, which in fact is the product of all these numbers. A couple things that you should know. This I could actually start at 2, not 1, and that's because the product starts at 1, and so you don't need to multiply that by 1 again. That doesn't have any effect. Another thing that's interesting is if you put in 0 here, I don't know if you can tell what it's going to give you, but the answer turns out to be 1 by our method, because this for loop is not going to execute at all, because 2 is not less than or equal to 0. So that may seem like a problem, but it turns out that mathematically 0 factorial is defined to be 1. And I won't get into the reason for that here, but that is something that in a math class, probability or statistics, you might discuss. Something that is a little bit of a nuisance is if we put -1 in, that gives us a number like 1, which negative factorials are kind of weird. It's not supposed to be 1. So we need to add a precondition here, or a rule that says that we should not call this function if n is less than or equal to 0. So the precondition is our input should never be negative. Something else interesting happens when I put in a number like 13. And to show you what weird thing it is, I'm going to print out the product as it's being generated by the for loop. So I'm going to run this, and it's showing me all the intermediary products. So 1 times 2 is 2, then times by 3 is 6, times by 4 is 24. And if you follow this, the numbers keep getting bigger, 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 until suddenly right around, oh no, 13 still works. Is that true? I thought it was 13 that broke. All right, let's try 14. I'll figure out the right number. When we get to 14, yeah, 14 is where it breaks. If you notice, from here to there, it's like, great, it got bigger. And then when you multiplied by one more number, it got smaller, which is weird. And the reason why is that there's a maximum integer value. And at this point, we've exceeded that maximum value. Let's see if I can bring up a calculator real quick to show you. So the real value of 14 factorial would be, let's see if I get my calculator here. Here it is. So 14, and then do I have a factorial key? Yes, I do. All right, hit it right here. There it is. 87 billion. That's great, except for the biggest integer that Java can hold is 2 billion-ish. So can't hold it. Let's try 13 billion and see if that one's held too. Nope, 13 billion is too big as well. So even though it looked like this number here was right, 13 billion, still too big. The largest number that Java could actually hold would be 12 factorial, which is about 479 million. So we need to add another precondition to here, which is that we need n to be less than or equal to 12. And if we do that, then if we keep to that precondition, then this method works totally fine. So a quick summary of what we talked about today. We looked at how you can call a function that calculates a value with a loop and then returns it. We also talked about how, as a reminder, that integers have a maximum value, and if you exceed that maximum value, weird things start happening with the numbers. Specifically, it starts to wrap around, and because we wrapped around so many times, it gave us another positive number that didn't make any sense. So this method only makes sense for numbers between 0 and n, or 0 and 12. And run it, and there's the product of all the numbers from 1 to 10. And that's it.